Stan Gibilisco here, with a view of a giant gaseous cavity within star-forming region NGC3324, courtesy of HubbleSite.org. It's my wallpaper of the moment, but that's not the topic of this video. This video has to do with a very important subject you'll find in my book, Teach Yourself Electricity and Electronics, 5th edition, a link to which I will provide in the description of this video. A link to the Amazon page, so if you like the book after browsing through it on that page, you can purchase it. Please don't pirate it. You get a bound copy if you purchase it, and it's a beautiful book, I'll tell you. I know, I wrote it. This is the first type of oscillator of several types I'd like to show you, just very briefly so you can identify them. It's known as an Armstrong oscillator, and an Armstrong oscillator is characterized by a transformer that feeds some of the output signal back to the input out of phase with the out of phase signal to begin with. That is to say, the output here is out of phase with the input here, so you have to reverse the phase again, and you'll get positive feedback as a result. That positive feedback then can be tailored by means of a variable capacitor to produce feedback at a particular frequency, and that is the frequency of oscillation. Again, this is an Armstrong oscillator circuit, the most fundamental oscillator circuit that there is. This particular type of circuit is known as a Hartley oscillator. It employs positive feedback, just like all oscillators do, but it's a little bit less obvious that the feedback is occurring between the output and the input because of the nature of the circuit. Notice here too, we have an N-channel junction field effect transistor in the Armstrong example. Here, it is a PNP bipolar transistor that we're looking at. That's why you have the negative power supply voltage. But you can recognize a Hartley oscillator by the tapped coil in the tank circuit, which you tune to determine the frequency of oscillation. The third type of circuit I'd like to show you is called a Colpitts oscillator. It's basically the same as the Hartley oscillator circuit. In this particular example, we use a P-channel junction field effect transistor. The tank circuit which determines the frequency is here, and you can recognize the Colpitts configuration because there is a split capacitor and a tap between them, which goes back to the source, in this case, of the active device. But the split capacitor with a tap between them is the hallmark of the Colpitts oscillator, and the tuning is accomplished by means of this variable inductor. Now, if you don't like tuning a variable inductor, you can use a variable capacitor instead in a variation of the Colpitts circuit known as a series-tuned Colpitts. This particular device, you determine the frequency by adjusting the variable capacitor here. And again, in this device now we have an NPN bipolar transistor. I'm trying to vary the active devices a little bit to keep from getting too monotonous with this, although these are considerably different oscillator designs. But again, the split capacitor with the tap between them gives away the identity of this circuit as a Colpitts oscillator. And finally, a crystal-controlled oscillator known as a Pierce oscillator, which operates at a fixed frequency unless you employ some means to pull the crystal frequency slightly away from its normal operating frequency, in which case you have a Pierce VXO, or variable crystal oscillator. But this is a simple Pierce circuit, and you can recognize the Pierce crystal oscillator configuration by the fact that the crystal is connected between the control electrode, in this case the gate of a field effect transistor, and the output electrode, in this case the drain of the N-channel field effect transistor. So those are the 5 types of amplifiers that I have shown you here. I believe there are 5, aren't they? 1, 2, 3, 4, 5. Yes, you'd think I could count up to 5 by now. I'm over 60 years old. But in any case, all of this information and much more about oscillators can be found in my book, Teach Yourself Electricity and Electronics. Any edition, but in particular, this is the 5th edition to which I will provide the link. By the way, I'm an amateur radio operator, call sign W1GV, Whiskey 1, good vibrations. So, you ought to understand, if you're a radio ham too, what 73 means, but for those of you who don't, it means in ham radio jargon, best regards. And I will say so long from the giant gaseous cavity within star-forming region N, G, C, 3324. Until next time, so long.